Okay, perfect. So good morning, everybody, or I guess good afternoon, and welcome to another TST meeting where the Karthik and company from Samsung Research Institute in India will give us a presentation on AI-assisted automation framework. And I'll let you take it away, Karthik, and everyone. And again, thank you for doing this and preparing this presentation.
Thanks, Thomas, for the wonderful opportunity. It is a great pleasure to be part of ONOS community. So this presentation, I would like to have my development team, Sendil and Sudhakar, present things here. So yeah, Sendil, why don't you take it over? Yeah.
Okay. Thank you, Karthik. So hello, Thomas, and hello, everyone. Hi. So this is our third presentation in the series of AML assisted automation framework in ONOS. In earlier sessions, we established the need of AI in ONOS for operator cost saving benefits. Today, we will talk about a specific use case, that is resource optimization. We will demonstrate using analytics with time series model, how operator can optimize the resource usage. So this slide talks about how we have organized our presentation. Firstly, we want to reiterate on importance of traffic prediction. We will shortly walk through limitation and benefits of with and without traffic prediction from operator point of view. Also, we will touch upon architecture and design consideration of facilitate ONOS integration with any third-party AML server. We will present a real operator problem and showcase the benefits of our proposal. So finally, we will conclude with offering ONOS components. So this slide has three sections. First one is AS, 2B, and core use case. First, we'll start with AS, as is. So this shows the relevance of traffic predictions, where in existing without AI, operator has to manually screen the data for any bookkeeping purpose. This is cumbersome activity and it prone to manual error. So next is on 2B. 2B is the desired situation where the operator can run through their intent like deployment assistance to anomaly detection without any manual intervention. One can view these attempts as a formative steps to bring intent-based networking to the ONOS controller. As the service scale, it not only adds to manual overhead, but it also attracts operator cost equally in commissioning manpower. Operator has to deploy manpower overnight, anticipating lean period to monitor the traffic to handle any maintenance activity. With well-defined automation system in place, now operator can automate the entire resource monitoring process irrespective of topology size and handle deployment smoothly. We will demonstrate how we are automating the resource monitoring procedure in subsequent slides. Okay, let's start with case study. As we know that SDN is used as FCAPS in all forms of transport network for the use case which varies from enterprise to telecom service. Even though SDN can facilitate network with ZTP, we wish to bring intelligence in the next generation of SDN. In typical data center would have thousands of bare metal servers and network elements. As the data center grows, we have many nodes to take care. It is very difficult to undergo any maintenance activities like software upgrade, hardware resource management, network operations, etc. manually. So definitely there is a need for automation. So let me illustrate the dig of the problem. So here we discuss a common case study in one of our service provider network. So this network has 2 access layer and 1 core data center. It has 2 UPF which are running on the 2 bare metal server in the data center. Additionally, it has ONOS and MANO application to manage and automate the UPF in the core data center. Here we can see the maximum capacity of access to core link is 25 gig. And the link between leaf and UPF is 10 gig. The port statistics are collected by ONOS to know the real-time traffic bandwidth in the link between leaf and UPF. So now the traffic starts from access to core and from core to another access node. So then right bottom side, we have the color representation of traffic bandwidth. So now the traffic flow starts from 18 gig. It will be equally split into 9 gig on each UPF. So here both UPFs are running in the load balancing mode. So now it is 12 gig. It is split into 6 gig on each UPF. Further, it is reduced to 10 gigs from access to core, which is split into 4 gigs on each UPF. But as the link capacity for one link can go up to 10 gig. One UPF is enough to manage the entire traffic flow. This is the right time to undergo any maintenance activity in any one of the UPF. To automate the maintenance time window, ONOS will know the bandwidth of both UPFs. It will inform to MANO, which further puts the UPF into maintenance mode, and it will perform any list of maintenance activity. Now one UPF is in the maintenance mode and another one is in functioning. Let's consider another scenario. So where traffic is increased. So now when one UPF is functioning and where another UPF is in the maintenance mode. So this will lead to the traffic loss. To handle this kind of scenario, so we will bring the AML approach into this. So which will predict the traffics in advance, so that ONOS will inform MANO to turn on the UPF, which is in maintenance mode, before actual traffic starts. So this AML and ONOS combinations will proactively prevent the traffic loss in the service provider network. So we have fair understanding now that AML brings to a lot of benefits to ONOS automation. Yeah. So now I would like to hand over the session to Sudhagar, who is working in the AML design and development.
Yeah, thank you, Sindhil. Hi, Thomas, and hi, everyone. So we have seen that how AML is benefiting our all the applications residing in ONOS. So let's see a glimpse of the popular AML frameworks available in the market. So these are the list of the frameworks and what generally framework is. So the frameworks act as tools, interfaces, or libraries that provide abstraction for any developers or non-developers, which mean non-ML experts, to develop ML models very easily. And on top of this set of frameworks, there are some ready-made ML platforms available, so which will create an interface between the applications and the AML frameworks. So here are the few available platforms currently, and here we choose MindsDB over other agents because MindsDB is an open source tool and it has much flexibility in providing the integration with multiple popular databases and multiple popular AML frameworks. And one more thing is like we Samsung are closely contributing to MindsDB. We are contributing some common APIs which we will related to this work. And the next thing is, like, we will show how the ONOS is integrated with the MindsDB agent. So the ONOS will create a REST interface between the MindsDB and the ONOS, and the MindsDB will further connect to the AML frameworks and the databases. Similarly, we expect ONOS to integrate with any other agents in the future through the REST interface. So for example, we have in our roadmap, we expect to create a REST interface between the H2O, which is the another ML platform available. So this is how we are integrating the ML platform with the ONOS side. So next thing is, here we have demonstrated our case study, resource monitoring. So here you can see the analytics framework section in the ONOS side. So it contains all the common APIs that are created by the MindsDB. And you can see that these common APIs are common to all the applications that are residing in ONOS side. So in our case study, let's take an example of resource monitoring application. And you can see every APIs are extended from this analytics framework. And each API has its own specific purpose, which the application needs according to their business logic. And one more thing I have to mention is this use custom model. So what generally MindsDB offers is, it offers a great flexibility to the applications. So like they can choose their own ML models, like which one they need to train, like in the modern world. And they can also choose the parameters which they need to focus on while training. Like they can provide their business logic as a template to MindsDB, and MindsDB will take care of the training and the results prediction purpose. So this offers very great flexibility to ONOS, and MindsDB can be an agent to provide all the popular AML intelligence and frameworks to the ONOS side. And this will definitely will not be a fixed thing, and it will the MindsDB has some more flexibility, so we can add any future AML frameworks into it and we can make it work well. So I hope that this is clear. And so let's dive into the demo. So these are the APIs that are available in the resource monitoring that we have created in MindsDB side. And these are the CLI commands which we will invoke in ONOS CLI interface, which will route to these APIs. So let's see them one by one. So these are the terminals available. Let me turn the video. Yeah. So these are the terminals which we will show in this demo, and this is the ONOS environment terminal. So you can see we have built the ONOS here and we have made it run locally, and these are the logs and stuffs. And this is the ONOS CLI interface. So here the ONOS CLI contains the analytics framework CLI, which we have discussed before, and also all the application CLI. And this ONOS CLI will interact with MindsDB through the REST server. And the next thing is MindsDB terminal. So we have built MindsDB using Python kits and we have run it locally here. And we have exposed this MindsDB through the REST interface, and the owners can access it really within the URL. And the next thing is, like, these are the APIs we have created in MindsDB, and we will show you later. And this is the data set which we have collected from the NetFlow collector. And you can see the schema of the data set, and you can see it is the data we have collected for around 1 month for all the router traffic bandwidth. And you can see this is the sample data of that, and we have included date field here because it is a time series data set. And this is all about the data set which we have stored in MindsDB side and for the AML processing. And let's dive into each API once at a time. And the first API is we are presenting the capabilities to the operator. So generally what will be the first step is the resource monitoring application will request the analytics framework to call the present capabilities API. So the analytics framework will interact with MindsDB through REST client, and the MindsDB will call the query processor, which will fetch all the templates that are made from the database, from the data set to the query processor. And the query processor will give it to the MindsDB, and MindsDB will provide those templates to the analytics framework, and the resource monitoring will get those templates. And let's see the simple format of that, how the capabilities will be. So in our case, it's let's consider it's a lean period prediction. And the template will be like you have to predict by router IP or by port or by router IP plus port or by timestamp. These are the general combinations which we get from the sample data. And let's see how this demo works. So yeah, so this is the command for that AML show templates, and this will fetch all the templates that are stored in file system in our MindSTB. So let's see how it works. And let us show the snippet for that. Yeah, this is a snippet for that. So here you can see like this is the templates, and it will get all the templates from the file system. So the templates will be in JSON format, so it will return the templates to the ONOS. So yeah, and let's see how it works. Yeah, so we got all the templates available, and yeah, one more, sorry. Yeah. Okay. So here you can see the templates we have got, and you can see the selectors field will tell these are the parameters you have considered to train. And the target field will say which is the parameter we have to predict. And grouping generally means that each parameter can have multiple values, so the application can request whatever value he wants from that field. And this duration space, the training data, the amount of training data we have considered, it's around 2 weeks, and the future predictions will say the duration which we are predicting. And yeah, this is the format for the template. So now the application knows what are the templates available from the data set, and so the application now will choose the template with template ID, and it will give it to the analytics framework. So the analytics framework will, as usual, it will interact with MindSTB through REST, and it will call the query processor, and the query processor will fetch the correct template ID from the model template store. And the query processor will ask the prediction layer to start training. So the prediction layer will fetch the data that is needed for the training, and it will start training and store the models. So it will just prompt the analytics framework that the training has started, and the application knows, okay, the training is started for that particular template. So let's see how that demo works. Yeah, so this is the command AML choose template, and this is the template ID which the application is giving to the analytics framework. So it has chosen one over here. So now let's see how let's see the snippet of that. So you can see it is connecting to the MindSTB engine, and it will just start the training using a simple SQL query. So let's see how it works. So yeah, that template is chosen one, and the training is started. And one more thing is that application can check the training status whenever it needs with the template ID which requested before. So for timely purpose, we have already trained here. So you can see the status for the model is complete, and the accuracy is around 81%. And these are some further more details. So the next thing is like the user can also know that the list of trained router devices and ports, so that he can give that particular values as a input to the queries. So this will be known via this command AML train list and the template ID. So we will get the list of IPs that have been trained, list of ports that have been trained, and the combinations that have been trained. So IP and port. So yeah, this will be more helpful for the user to give the query parameters. Yeah. So the next thing is the template has been trained, let's assume. So now the user wants to make the predictions. So the user really wants his business logic to work out. So what he requests the MindSTB is, you have to please provide all the queries available so that I can make use of the queries according to my logic. So it is same as requesting the templates. So it will request the analytics framework, and the analytics framework will interact with MindSTB through REST, and it will call the query processor. And in model template store, the queries for that particular template ID will be stored there. So it will be fetched, and it will be returned back to the application. So let's see the simple format of that queries. So here for lean period prediction, so it is showing that, okay, you can predict timestamp and bandwidth by giving IP as a value, or you can predict timestamp and bandwidth port by giving IP plus port as a value. So these are the combinations which we have seen in previous slide. So the combination is trained, and we can choose from this format anything. So yeah, so let's see how this demo works. Yeah, so this is the command for that AAML show queries, and we will give the query ID as our parameter, and sorry, we will give the trained template ID as a parameter. So for this template ID, so the queries will be fetched from the file system, and you can see this is the code for that, and we will fetch all the JSON files here, and we will return it to the ONOS application. So yeah, you can see this is the answer we got. So it shows that this is the predicted map with the template ID, template 1, and you can see the select assist date and bandwidth, and you can see IP, enter IP address, which is mandatory to give, and the other fields, port, window, bandwidth threshold, they are optional. So this is just a simple query format that we are showing to the application. So now the application knows what are the queries he can query, what are the formats he can query. So now he will, with help of that query ID, it's similar to template ID, he will give the query ID to the analytics framework, and if he needs to specify the arguments by himself, then he can also provide those arguments. So the arguments on the query ID will be passed to MindsDB. So MindsDB will give those things to query processor. So the query processor will fetch the respective query using the query ID from model templates, and it will give the query plus the arguments which we have passed from MindsDB to query processor to the prediction layer. So now, based on the query ID and arguments, the model will be selected by mapping, and the prediction will be made. And once the prediction is made, so the prediction results are given back to the application. So let's see how what's the format of the output. So it will be like predicted lean period for the given query parameters, and the parameters can be IP, port, window, and bandwidth threshold. So let's see how this final API demo works. Yeah. So here you can see I have given us AML resource monitor query because this prediction query is specific to our resource monitoring application, and we have given the query ID as 1. From this above you can see the query ID is 1, so you have selected that, and we have given the arguments IP, port here. So this query request is sent, and we are waiting for the response here. So in MindsDB side, you can see the prediction is being made, and all the processes, pre-processing, and the prediction is running here. Yeah. So now we got the predict runtime here as 48 seconds. So, and we are getting the result here as predicted lean period is 11:30 and the window is 15, which means that from 11:30 to 11:45 is the time where the traffic flow is minimum. And if the user has to specify some more arguments, like he will give his own window time, like predict the best 30 minutes, predict the best 45 minutes. And also he can, in the case study, we have discussed about the bandwidth size, right? So he can give that bandwidth also as an input here, like 10 GB or 12 GB something. So you can see here, he is giving us 45 and 1000. Wait, I will show it via pointer. So you can see he's giving the window as 45 here and the 10 GB as a value here. Mm-hmm. So the query request will be made, and the response we are getting here is 9:30, and the window is 45 minutes. So I will say now how it helps in our case study. So we are predicting that from 9:30 to 10:15 for 45 minutes is the best time where the traffic flow will be minimum. So in our case, 1 minute. So in our case study here, so as Sendil has said, when the traffic has been suddenly increased to 15 GB, so there will be a traffic loss as the maximum bandwidth is only 10 GB for a particular link. So to avoid this anomaly, if we have introduced this AAML approach, so and we have got the results as the prediction is made as 9:30. So which means that before 9:30, this maintenance activity has to be done. So I mean, like this UPF has to be maintenance activity in this UPF has to be done. So with the help of that prediction, we can assume that we can avoid these anomalies here, and we can make this run smoothly without any traffic loss. So this is one of the case studies, like how we are used to explain like how really AML is benefiting our applications, our ONOS automation. So I think I have ended here. So yeah, I'll check once. Yeah, so that is the part of our demo, and these are the open source components in our proposal. So you can see the 1 minute. So you can see like we are using some existing components in ONOS, and we have also proposed some new components. So the first thing is NetFlow collector component. So it contains the flow controller, flow collector, and message decoder. So it will just collect the data from the switches and it will store it. And this right hand side is completely the AML port. So you can see the applications here. So for example, in our case, it's resource monitoring, and the other applications can be anything based on the user needs. And this will be the internal workflows that are connected to this application. So which is the existing component available in ONOS. And this will be analytics framework and AML controller. So analytics framework, I believe that I have explained it before. So it contains all the common APIs available, made available by the MainSTB. And AML controller is a connector between the ONOS applications and the MainSTB. So, and it will provide the services like the training service and the prediction service. And these are all the open source components we are used, and you can see the analytics data store here. So it's just for like comparing the results with the actual data, and really we can like use some visualization BA visualization tools, and we can make it really more big comparing to this. And yeah, this is the development phase. So the first thing is flow protocol integration. That will be our initial phase, which we will integrate the NetFlow collector tool, which will collect the data from switches and store. So like I explained in the previous slide. And our second phase will be integrating the ONOS applications with MainSTB, where the MainSTB will further integrate with the AML frameworks. And the third phase will be we are enabling the AML intelligence to the applications in the ONOS through the MainSTB agent. So yeah, these are the development phases we are currently proposing, and yeah, so that's it from my side. And thank you all. So if you have any doubts, like you can ask, please, always welcome.
This is a very nice demo. Thanks, Ricard. Thanks, everyone.
Yeah, thank you, Thomas.
So I had, I guess, a couple of questions and comments. So I think I definitely like the approach of using the REST API just to basically, keep because ONOS is primarily for kind of real-time control, right? So it's not really suited for holding huge amounts of data or historical data. And so that's definitely, I like the recoupling provided between the ONOS applications that are running inside ONOS and then the rest of the machine learning and prediction framework. So that's a great approach. Second is, if you wouldn't mind maybe going back a couple of big slides, if you wouldn't mind, so that we could talk about some of the sure. So in here, yes, so a couple of things. So the new components, the NetFlow collector, so these are going to be basically components on a left-hand side here. New components that you will create to be able to basically collect the flow information from the flow collector software, right? From the environment. Is that correct?
Yes.
Yeah.
Yes, Thomas. So this would be collect the network traffic data from switches and then it will pass that net flow packets. Then this will be pushed to the MindStv.
Okay, perfect. That was my question. Is this is primarily just for extracting the information from the environment, but not storing it within the realm of ONOS, but instead kind of immediately feeding it and streaming it into the time series database, which sits outside of ONOS, correct?
Correct. Exactly.
Okay, perfect. I think that's a good approach, because again, you know, ONOS is not necessarily designed to hold huge swaths of historical information. It's not optimized for that. And there's plenty of you know, off-the-shelf solutions for being able to do that. Okay, so that's great. So that answers my question. The second question I had was with respect to, so in your demo, you showed how you were able to kind of download the list of templates and then basically train a certain template, initiate training of a certain model, right? Corresponding to the template. Do I have that correct?
Yeah, exactly.
Yeah. So, but in your demo, clearly there was a kind of a manual kickoff of that training exercise from within the realm of ONOS, right?
Yeah.
Do you envision that was this just for demo, or do you envision that this would be kind of the standard use model for operators, or do you envision that the kind of the training could be triggered really from, you could trigger it from anywhere, or could potentially also be kind of periodic happening in the background, just so that, you know, basically you constantly revising the model, right?
Yeah, exactly. It's just for the demo.
Okay, perfect. Okay, because I think there would probably, because, you know, as clearly there is some trend information, but there also the trends evolve and the situation changes over time. So
Yes.
I think it would be important to constantly keep training or retraining those models.
We have to periodically retrain to maintain such trends and seasonalities.
Exactly. Yes. And then you basically would just, you know, upgrade your model to the latest one.
Exactly.
Okay. And okay, so that answers my question. Thanks. And another question with respect to the, you know, the inference, right? When you actually run the inference. So in your case, the demo was basically, there was kind of a singular event for initiating the prediction, or kind of initiating the inference, saying, okay, well, we need to run a maintenance on this machine, and we want to look for a, you know, window of 45 minutes for, you know, certain where the 10-bit is, where the bandwidth is going to be dropping below 10 gigabits, right? And so that operator basically can ask a specific question, and the inference engine will give them an answer if it has one.
Yeah, exactly.
So I definitely see a use case for that. Do you see what kind of other questions do you envision that either operator would be asking, or do you? So there's one, you know, where you would have an operator asking specific questions with respect to utilization. I would also expect probably maybe the same kind of similar question could be asked, but in a negative, where you could, for example, say, well, when are we going to run out of bandwidth, right? For future equipment planning. It could potentially be also interesting. Yeah, this is really nicely done. What other kind of questions do you expect the operators would be interested in?
There can be also some kind of anomaly case where suddenly some kind of malicious user is kind of trying to access or pump the data, huge data into network, and this can degrade the network performance. And so we can also observe the network, and we can also kind of predict for any anomaly based on KPIs, performance monitoring KPIs. This can be another use case. Anomaly detection.
I see. When you have this departure from expected patterns of traffic?
Yeah, when you deviate, when the KPIs deviate from the normal behavior. Sorry, did I answer your question?
Yeah, I think so. Yes, you did. Yes.
Yeah.
And so, so right now it's primarily at the prototype stage that you were using the demo for, or was that just a mock-up, or was that actually just as a like a proof concept prototype level code?
Okay. So this is a formative step. So if the flow, especially the way we kind of organized the software components here, if the owners committee in particular, if you are okay with this kind of approach, then we will make it more formal. We'll make it modularize, and we'll keep on adding the necessary features. So we thought that we'll do a dry run with the POC and get a concern of this understanding what we have. This is how we want to design those components, and if these components, modularity is fine, then we thought that we'll go ahead with the incremental approach by bringing more components here.
Yeah, no, I think this this approach is perfectly fine. I mean, clearly, I mean, it's something that's it's modular enough, and I don't think it really necessarily, you know, in a sense, you don't really need a permission, obviously, because it's not something that's you know, deforming the existing ONOS core, and it's just something that layers on top of that. So I think this is perfectly okay, and so, you know, all kinds of experimentations are really welcome. There's relatively few rules, right, with respect to contributing to the ONOS, as long as it doesn't deform the core, and kind of it's a perfectly fine approach. So
thanks, Thomas. So we could assume this as a green signal, and we will go ahead by adding feature. Yeah.
This is nice. What version of ONOS are you planning to build this on? Are you planning to starting to build on a 2.5 or no, oh, sorry, on 2.7?
Sendil, what do you think?
What? Yeah.
Hello. Can you repeat your question, Thomas?
He's asking which version we can start thinking of.
Are you working off of the latest LTS or just the latest?
We'll start the latest one.
Okay, that makes sense.
Yeah.
Great. Yeah, no, this is a pretty cool project.
Thanks, Thomas, for the encouragement. Thank you. Yeah, our team has spent a lot of effort. I mean, especially gone through weekends and made this attempt. So hope you liked it, and also I'm happy that you liked it. So
yeah, it was a very clear presentation as well. So it's definitely makes a lot of sense to me.
Okay.
I think it's a very interesting way to kind of, you know, combine both kind of the acquisition of the real-time information from the network environment, and then feeding into basically then capitalizing on it by engaging the kind of generic machine learning framework of the show. And I like the use of the MindSTD.
So sure. And one general feeling is, Thomas, I mean, since this is a kind of a common thing in place, so it can be applied both in enterprise and telecom. So is it okay if we can kind of push this idea for SD-RAN also? Will it work? Or
yeah, so for SD-RAN, for sure, the only thing is the SD-RAN project currently is based on micro-ONOS. So I think this is where like, and this is one of the reasons from the last meeting, I kind of suggested that you externalize as much of this as possible from ONOS itself. All right, basically just use ONOS to acquire the data and then feed it externally. And then from then on, you can just engage with the AI framework on its own.
Mhm.
right? The benefit of that particular approach is that it doesn't depend on ONOS Classic very much.
Mhm.
And then it can be much more, it can be much more easily ported to micro-ONOS because the touch point is minimal, right? The touch point is basically just ONOS tells you about the topology and about the utilization of the network. And that's all you need, right?
Yes. Right.
Then of course, then you could, as you can then run you run your trainings, you can then run whatever, inferences you need to run, basically formulate whatever questions should be asked, interesting questions about the environment. And then in response to those questions, you can then externally drive ONOS to make changes to the environment as necessary. So ONOS in here is basically just a source of the information about the environment and the set of basically actions that you can and means to perform changes to the environment, right? In terms of the flow control, right? Be able to redirect stuff around the let's say part of the network that needs maintenance or whatever. You can adjust the network behavior. And that would be the same thing with ONOS, micro-ONOS. And so if you design it so that it's relatively external and has a lot of relatively crisp interactions with ONOS in terms of extracting information and be able to accept some actions, then it'll work. It'll be fairly easy to adapt to micro-ONOS as well when micro-ONOS is ready to do this. But today, like I said in the beginning of our meeting, I think this is before we started to record, we're just embarking on the journey with micro-ONOS, where we're kind of returning to the realm of as true SDN control. Because up to this point, we've been primarily focused on SDRAN and on configuration. And so to answer your question, original question, after some detours here, with respect whether this would apply to SDRAN, I would definitely see so. And I think the benefit of architecting it where it's somewhat separate from ONOS Classic would then be that it should be much easier to integrate with SDRAN, which is built on top of micro-ONOS rather than ONOS Classic.
Yeah, thanks for your inputs.
Hopefully that answered your question in a roundabout way.
That really helps. Yeah, thank you.
Okay. Well, I don't really have any other questions. I know that briefly we had Charles join us, but I think he had to run off for another meeting.
Okay.
So I don't have any other questions. This is great. So I assume you're going to be starting to full board development on this.
Yes, Thomas. So we will phase it out. So maybe in another couple of weeks, we'll get back with the plan and our phase-wise approach we'll discuss.
Yep.
Yeah. Okay.
No, that's great. And again, thank you for the time you spent on preparation for this and a really nice demo.
Thank you. Thanks, Thomas. Thanks, Dee. Thank you very much for your time.
Yep.
Yeah. Thank you.
Thank you, Thomas.
No problem. I guess we'll hear from you later then, right?
Yeah, sure.
Perfect. Okay. I think with that, we can conclude the meeting and stop the recording. I'm sure we'll chat with you later. Bye-bye.
Yeah. Bye. Yeah.